Okay, awesome stuff. All right. So let's not waste any more time. Let's get right into it. I'd like us to start by doing activity 2. Okay, I've got the answers right there on screen for you guys. Okay, and then we're going to do them together. I'd like you guys to try and tackle them there in the chat. Okay, right. Do remember that when it comes to this module, it's really just practice. Otherwise, for a lot of you, I'm sure this is a recap on what you've already done in high school or have done during your time in school, which is perfectly fine. That said, let's not waste any more time. Let's jump straight into it. So, given that x is equals to 6, determine the value of the following expressions using substitution. So what then would be the total for A if we substitute x with 6? All right, I hear something there in the chat. Okay, so let's see what you guys are saying. Okay, 33. Let's see, how did you guys get there? So you're saying this is equals to 5, 6 plus 3. Okay, so in other words, 5 times 6 gives us 30 plus 3, and we have 33. Okay, awesome stuff. Let me just zoom in there a bit. Maybe it'll help me to write a bit smaller. Okay, so you guys are 100% correct. Thank you, Oliver. Thank you, Tikani. Okay, let's get back to it. Okay, B, we have, all right, 12, all right, minus 4 brackets 6. What do we get? Okay, so 4 times 6, we get a 4 times 6, we get 24. Yes, so 100% right. That becomes then a negative 12. Negative 12. Thank you, Oliver. Thank you, Teo. Okay. Then for C, what do we have? We have x, or in other words, 6 to the power 2 plus 4 to the power 6 minus 20 is equals to what? This is equals to what? What is the answer over there? Oh, actually, I see I am in error. This should actually be 6 over here. Okay, so here it's done a little subscript thing, but it should actually be lowercase like that. Is that it? Is it just supposed to be 36? Teo, is it just supposed to be 36? Kate Kani, is it just supposed to be 36? Can we leave it just at 36? I see you saying yes. 6 to the power 2 is what? 36. And then 4 times, yes, 4 times is going to be 24. So that's going to be, no, yeah, no, it's not going to be 36. So what's our final answer? Maybe we should break it up.
So
what answer? Yes?
when we put in the calculator, we get 36. But if you just put the 4 to the power of minus 14, you get some very strange number.
Okay, so let's work this out. I'm quite curious as to why you're getting that. So 6 to the power 2 is the same as saying 6 times 6, right? Which is then going to give you 36 plus 4 times 6, you get 24, all right, and then minus 20. Okay, so 36 plus 24 is going to give you 60. This is going to give you 60. All right, and then plus 20, minus 20 should then give you 40. Okay, so I don't know how the calculator is doing it. I think they maybe, yeah, I don't know what the calculator is doing that's making us not get the right answer there. But yeah, your final answer should be 40. Yes?
So you see it's 4 times 6. It's to the power x minus 20, not times 6 minus 20. It's to the power of.
Okay, so when I look at in your workbooks, in your work manuals, I see that they've actually when I copied and pasted it right here, it is, yeah, to the power 20. That's how it was copied. But when I look in your work packs, it's actually x to the power 2 plus 4x. Let me do this. Minus 20. Does that make sense? So this, it just copied it wrongly, but this is what it should actually look like. Are you guys with me?
Sir, what page of the workbook?
Yes. I'm on page 62.
Thank you.
Okay, so I'm just erasing this so I can have space for this last one. So this last one is correct. So for D, what do we get? We have 2x to the power 3 plus 10. What do we get? Okay, let's see what you guys think. Shit. 442. 442. So let's work it out and see. Thank you very much, Oliver. Okay, so this okay. Then obviously we need to resolve this first. So once we resolve that, 6 to the power 3. So let's see, what is 6 to the power 3? I'm sure you guys have calculators there on you. So 6 times 6 times 6 gives you, all right, 216. 216 then times 2. I don't know why it's done that twice. Okay, but then you should have 432, as you can see over there, plus 10, which then gives us the 442 that I think it was Oliver came up with. Okay, 100%. All right, thank you so much, Oliver. Right, and that's the first bit. Then we move on to the second bit. The second bit, they want us to expand the brackets. In other words, we want to expand these expressions, okay? So the first one seems pretty easy. It's 6 times 15 plus 4 in brackets. So here what must happen? How do we expand these brackets? How should we go about this, guys? Somebody tell me. What is the answer over here? What do we need to do? 114. Okay, and how did you get that? Let's see. We're saying, okay, yes, we are saying 6 times 15 plus 6 times 4, 100%. Okay, let's quickly check to see if you guys' logic is 100%. 6 times 15. This calculator doesn't like me. 6. Yo. Okay, we get 90. 90 over here. Plus 6 times 4. Okay, and then we get our 114, as you guys stated. Okay, perfect. Happiness over there. Okay. Then with the next one, again, for some reason, it's creating its own subscripts and stuff like that. Okay, so I'm just going to quickly, let's do this, just to create more space. Just going to rewrite it out nicely there for you guys. So 2x, all right, to the power 2, and then y, okay? Then 3xy to the power 2, okay, minus 4x to the power 3, y to the power 3, okay, right? So here again, we're just multiplying, okay? So what is the answer that we are going to then come up with? what is the answer that we are then going to come up with over here? Do I have any takers? How are we going to expand this particular problem?
Sir,
Yeah, boy.
can I just tell it to you because I don't feel like typing it out. It's too much information.
All right, cool.
That's 6x squared, x cubed, y cubed.
6x. You said 6x squared or cubed?
Cubed.
Okay. And then?
Y cubed.
Y cubed.
Then minus 8x to the power 5, y to the power 4.
Y to the power 4. Okay. All right, cool. So how did we do this is the next question. Okay, I agree with you guys' final answer, but then how did we do this? We simply said 2 times 3, okay, which gives us the 6, okay. Then we said, okay, we've got an x here to the power 2, and we've got an x here, which is in effect to the power 1, okay. So this x to the power 2, then it becomes x to the power 2 plus 1, okay, which then gives us obviously this x to the power 3, okay. Then we do the same thing with the y. We are saying this is y. Let me actually do it with a different color. This is y to the power 1, and then obviously this is y to the power 2. So we're saying 1 plus 2, okay, which then obviously gives us 3, okay. Okay, so that's how we're getting the 3 over there. Then we are saying minus, again, this 2 times 4, okay, which is then giving us 8, okay. Then this x cubed, we're saying, okay, x to the power 2 plus x to the power 3, so, all right, plus 3, then gives us x to the power 5, okay. And then we deal with y. Once again, that y is to the power 1. Okay, so 1 plus 3, this 3 right there, okay, which then obviously is giving us the y to the power 4, okay, which is exactly what you guys then got, okay. Awesome stuff. Awesome stuff. Okay. Right, so we're then done with that section. So then let's move on to the next. Now here, what are we doing? We are now factorizing. So here, now we are factorizing. In other words, we're now simplifying. Okay. We are now simplifying. How do we go about that? How do we go about that? And you can switch on your mic if it's easier for you guys, and then you can tell me what it is that you have arrived at. And then we can figure out how you got there together. So how are we going to put this within brackets? Okay, again, I think here they've kind of messed it up a bit. A should be 8x to the power 2, y to the power 3, okay, minus 12x to the power 3, y to the power 4. Okay, that's what it should look like. I think the first point of departure should be what number goes into 8 and what number goes into 12. Maybe we can start there. What's the biggest number that can go into both of those? The biggest number is 4. Yes, it is 4. Dashane, it is 4. Okay. So let's jot that down. So we have 4, okay, which can go into both of those, all right? Then in both of them we have X and we have Y. So we know we're also going to have X and we're also going to have Y on the outskirts there, okay? So what else? What else can we do over here? Is there anything else we can do?
Sir,
Yes.
we can put both x and y to the power of 2.
Okay. Okay, why are we putting both to the power 2?
Because I don't know, but I just know that.
Okay, so you're on the money there. All right, you are on the money there. But if we say what we can also do is we can actually go with the first one, right? And we can actually go on to say, okay, cool. We can even make this to the power 3, okay? Just to take care of the first one, okay? So then what it would be is if this goes into that, it would be times 2 this, okay, to get into when we say when it goes into basically divides into that. So in brackets, we would then have 2, okay, then minus over here. Let's see, how many times does 4 get into 12? It goes in 3 times, okay. But then here we have x to the power 3, and here we have x to the power 2, okay. So then that would make this x to the power 1, okay, which is the same as saying 3x, okay, because remember we don't usually say to the power 1, okay. It's as good as leaving it blank, okay. Then here we have y, okay. Then obviously this is 3 and this is 4. Again, we have a situation where this is 1 above. So then again, we could say y to the power 1, but again, we don't do that. We simply just leave it as blank like that. All right, and then obviously that then would solve our problem, because if we times this 4x to the power 2 and then y to the power y cubed, we can then obviously then get this amount here, this 12 x to the power 3, and then y to the power 4. Okay, it's one of those. I think it's one of those. It's very hard to actually explain. I understand why you said, "Hey, I don't know." Okay, but that is exactly how you do it. And I'm sure if you play around with it, expand it, and then obviously simplify it, you'll then see that we are making sense. Okay, then this B is quite the same. You have, they've messed it up again in the copying and pasting. Okay, minus 12x to the power 2 y to the power 4 plus 6 x y. Okay. Okay. Again, we want to look for what can go into all of these. That's the first point of departure. What can go into all of these numbers? Okay, it can't be 2 because 2 can't go into 3. Okay. Right, so what then can we use? We would have to use what? Somebody tell me in the chat. What can go into all 3 of those numbers? The whole numbers. Okay. Hey. All right. Thank you, TK. You're definitely right. It is 3. Okay. Then we go on to say, okay, so we have that out the way. Then we know that there's an XY present in all of them. Okay. So we simply then put XY there. We can't necessarily raise it any higher because then it wouldn't be able to enter all of them. Okay. All right. So then we can put our brackets there. Okay. We can put our brackets there, and then we say, okay, so this is going to then be, can you see that this is going to get into that once, so we don't need, that cancels out that. Okay. But this is going to get into, okay, we're going to have 1 over there. Okay. So we can then just put x over here. Okay, typically it would look like 1x, all right, but we don't do the 1. Okay, and then we know that 3 to the power 3, that means that this is 2. Okay, so we can erase that. Remember, we don't put that 1 in front. And so we've dealt with this first bit. Okay, I hear something there in the chat, so let me get that out before I go any further. Do we have to follow BOMDAS with algebra? Yes, we have to follow BOMDAS all the time, but now in algebra here, we're only dealing with, how do I explain this? We're either expanding or contracting stuff, Jasmine. So with this specific question, it's not like we have to really apply BOMDAS because it's just one expression that we are dealing with here. But if it was like any other type of situation, yes, we would have to apply BOMDAS. Okay, but here we're obviously, yes, this is what I wanted to say. I'm just struggling to find the right words to say it. We're dealing with expansion and simplification. So with expansion, we're talking about multiplying, okay? And then with simplification, we're talking about, basically we're talking about division, okay? Because we want to put this expression in its simplest form. So can you see we're not doing addition, subtraction, division, multiplication at the same time. We're just doing multiplication when we're expanding, or we're doing division when we're simplifying. So there isn't a need for BOMDAS in this specific scenario. But if we were to be told solve the expression or solve the equation, and we have division, multiplication, addition, subtraction in the same thing, then we would have to use BOMDAS or BODMAS. Okay. Awesome. Okay. Right. Great stuff. So there we go. We have 2x. We've solved the first bit. Okay. We solved the first bit. Then we can go to the second bit. Okay. This is a negative, right? So 3 into 12, you're going to get 4. Okay. Then we know that this is 2x. So it's going to be, here it's going to be what? What is it going to be? What is it going to be? Can we leave it like that? Somebody tell me in the chat, is it fine? Or is there anything we need to do to the x? Remember, this is the same as saying x plus. Oh my goodness, what happened over there? Same as saying x plus, sorry, to the power 1. I don't know, you guys tell me. Leave it that way. Thank you very much, TK. Yes, we can leave it that way. Okay. We can leave it that way. All right. Then what must happen? We have y to the power 4. Okay. So let's put down our y. This is to the power 1. Okay, and this is to the power 3. So we are going to need to do what? What is this y going to be to the power of what? Y to the power 3, 100% TK. Thank you very much. To the power 3. Okay. Then we're done with the second expression. We can cancel that out. Move to the last one. This one is plus. Okay, so 3 into 6, we get 2. Okay, and then this is to the power 1. That's to the power 1. Okay, so we don't need to do anything there. Y to the power 1, y to the power 1. So we don't need to do anything there. Therefore, we can leave it like this. Just erasing this to make it all neat. Okay, that's our final answer. This is our final answer right here. Okay, done. Right. Then we can move on to the next one. Okay. And the next one there, it's question 4. Goes on to say, simplify the following algebraic expression. Okay, simplify the following algebraic expression. How could we simplify that? How could we simplify this algebraic expression? Okay, the easiest way would be to actually do what? To actually put like terms together. So if we put like terms together, let's see, this 3x would get together with that minus 5x, which would then give us a negative 2x. Okay, I'm going to erase that so things are clear. Then this 6y plus 4y would then give us a plus 10y. Okay. All right, that's dealt with. Then we have z. Do we have another z? Yes, we do. Okay, those two would then get together. So that would be positive 12y minus a negative 6y. Sorry, a positive 12z minus a 6z, which would then give us a positive 6z. Okay, then we have these two numbers. Okay, negative 4 plus 8. So we then have a plus 4. Okay, is there anything else we can do to this? Is there anything else we can do to this? Okay, for me, I feel like you could even divide this by 2 if you wanted to. All right, so I actually would go on. In your answer books, I see they leave it. I would actually go on to say negative x and then positive 5y plus 3z plus 2. That's how I would leave it, because they said simplify, right? So that's how I would leave it. But I see they obviously they went just as far as going to this point. Okay. Okay. Right. But that's fine. See, there's something. Oh, smart. Why, thank you, Mr. Grant. Thank you, sir. Okay. Right. So let's proceed. Let's proceed. We go on to B. Let me change colors here. Okay. We go on to B. I'm just going to erase this here. With B, we have this 9A minus 4C. Okay. So how then do we go on to simplify this? How then do we go on to simplify this? This negative is the same as saying -1. Okay. That's pretty much the same thing as saying a -1. Okay. So in order to remove the brackets, we need to times by that -1. Okay. And so we would then get 9A minus 4C plus 3A minus 8B plus 10. Okay, and then it would go on to be plus 3B minus 5C. And then again, what we do is we need to put like terms together. So 9A plus 3A, we then get 12A. Okay, so that's been dealt with. Sorry, don't need to erase that. Okay, I'm just going to cancel it out. Then we can say 4C, and we have another C over there. So we can cancel that out. So it's going to be a negative 9C. Okay, then we have 8B and 3B. Okay, negative plus a positive, that's going to give you a negative 5B. Okay, cancel that out. And then we have a positive 10. Okay. All right. Now these we can obviously not simplify any further. So that would be our final answer. Okay. This would be our final answer. Okay. Right. Everybody happy? Everybody happy? Everybody good? I hope. Okay, again, I'm just going to erase this just to create space. Okay, I hope that wasn't a question because I just erased everything. All right, awesome. Thank you, Grant. Okay. Right. Then this should be divided by. Okay. Just don't have that dividing line over there. Okay. So it should actually be 56x to the power 6. All right, and then y to the power 10. Yes, am I correct? Yes. Okay, and then here we have 14x to the power 3, y to the power 7. Okay, so this is pretty much the same as saying the following. Okay, so we can divide these numbers, 14 into 56. Okay, how many times do we have 14 get into 56? I don't know mentally. Let's do it on the calculator. 56 divided by 14. What do we get? We get 4. Okay, so we have 4. All right, and let's do it here. 4. All right, so this cancels out that. We have 4. All right, then we have x. All right, and we know that when it comes to division, all right, it's the same as saying 6 minus 3. Okay, which is then obviously going to give us 3. Okay, then we have y. Okay, and again we have 10 minus 7, which again is going to give us 3. Okay, So there we go. That should be our final answer. Am I correct? Yes. So that should be your final answer. Okay. Right. Awesome. Let's go on to number number D. To D, we have, is it written out correctly? Just double checking. Yeah, that looks about right. Okay. So first things first, what we want to do is get rid of these brackets. Then we can solve the rest of the expression. All right. So 32n, okay. Then we have minus 5 times 50, which will give us a minus 250. Okay, then a minus 5 times 8n, which should then give us negative 40n. Then a minus 5 times 5 should give us a negative, actually, that should give us a positive 40n. Minus 5 times a positive, that should give us a 25n. And then negative 5 times a negative 2 should give us a positive 10. And then finally, we have plus 105n. Okay. So again, like terms, we want like terms. So we take this n, we add it to that. It's going to give us 72n, and then minus 25 is going to give us 50, 47. This is going to become 47n. Okay, then we have another n, 105. So plus 3, that's going to give us 152n. 152n. Okay, so now we can cancel out all the n's. We've dealt with them. Then we have 250 plus a negative 250 plus a positive 10, which will give us a negative 240. Okay, and that is our final answer. All right, okay. I think we have one more, and I'm going to give you guys a break. So let's see, did they write this one out right? No. So this should be y to the power 5 minus y to the power 3 divided by 4y to the power 6 minus 5y to the power 8. Okay, again, here we can see that we do not have anything that goes, this 4 is not divisible into 1, okay? This 5 is not divisible into 1, because that's in essence what we have over here, okay? So what we then have to do is say, okay, cool, what then can we do? What then can we do? We then basically need to simplify on both sides, okay? We know that the smallest y that we have is this one, y to the power 3, okay? All right, so then we are going to need to say, okay, so we can put the top in brackets by saying the numerator, we can say y to the power 3, okay, then in brackets, here you're going to have y to the power 2, okay? Because 3 plus 2 will then give you this 5, okay? Then here it's going to be a negative. Then what we're going to say there it's going to be -1, okay? Because a -1 times y to the power 3 will then give us this. Okay? Okay, right. So let me erase that. Just wanted to show you the logic. Okay, there we go. That's our new. Ooh, I'm close to the next sum. Okay, so that's our new numerator. Then we want to solve this denominator. Again, we want to use the same y to the power 3. Okay. So this is going to be 4, because remember, we didn't have any whole number to simplify this. Okay. Then we are going to go on to say 4y to the power what? To the power 3. Okay. Because again, plus 3 will then give us this 6 over here. Okay. Let me just erase that. Okay. Then here we have a negative, and that's going to be 5, and y to the power 5. Okay, close brackets. And then we are done. That is our answer. This over here. Okay, right. And we are spot on at 420. All right, so let's take a break. Let's take a break, and then let's get back together at 4:32. Let's get back together at 4:32, and then we will finish off this activity. Are there any questions or thoughts? Please leave them in the chat, and then when we get back, we can then proceed with those questions.